So, first unit, topic 1.1, changes in tandem. So, honestly, super easy unit. Let's just get right into it. It's pretty straightforward what we got here. So, we have a graph here on the left side of the screen, and it's looking a little weird. It's doing a lot of random stuff. You see from 5 to 2, it's going down. It looks like an exponential graph. Or not exponential, but quadratic. And then on the other side of that, you got it shooting up rapidly in the span of, 2x values. And then, on the other side, you have a bunch of other stuff. So let's just get into this vocab right here. So we got local maxima and minima. So what that means is we're just talking about what are the high points, so the maximas, and what are the low points of the graph. So basically, what we got right here, that's a local max. So I'm gonna say we have a local max of x equals or at x equals -5. So we have a local maxima over there. Where else do we have a high point? At x equals 0, we got a super high max over there. We'll get into that later. So at x equals 0, we have another max. What else? I think that's, oh, no, this is technically a max right here. At x equals 11. Okay, cool. Now let's talk about the minima. So where are our low points of the graph? So we got one here. We got one here. So we have a local minima at x equals -2 and x equals 1. Okay. So pretty straightforward enough. Now, as I said earlier, that this is the highest point we have on this graph. That's called an absolute max. That's where our graph peaks out, caps out. So at x equals 0, yes, there is a local max, but that is also the absolute max. And where's our local, absolute minimum? It's going to be right down here. So x equals 1. There's also a absolute minimum. All right, cool. Boom. Done with that. Now, something else you'll probably get asked about is where is the graph concave up, concave down? What does that even mean? Okay, concave up, we'll get into the vocabulary at the end of this. We'll kind of do a takeaways. But for now, looking at this graph, where's my graph opening upwards, essentially, is what we're trying to see. So, right now, I'm seeing the graph opening upwards from here. Actually, let's use a different color. So the graph, because this opens up, right? So we're opening up. Still, the graph is still going up on this side too. Oh, okay, there we have a point of inflection. So there the graph is going to turn around. But from -5 all the way to 0, our graph is pointing upwards. So that's going to be our interval right there, -5 to 0. Okay. Now, concave down, where is the graph opening downwards now? So for this one, again, concave up is going to look something like this. Concave down, literally going to open downwards. So concave down, where does our graph look kind of like a U? I see that happening right here along this. Our graph, because if we were to pretend and continue this, it would go probably something like that, or it would just cap out at that. But it's still not opening upwards though. So we'd count that as, where does that start? It starts at 1 and it goes to 11. Okay, so that's where our graph is concave down. Okay. Now, the next thing we want to look at is concavity. So, where does the graph have? So we looked at concave up and we looked at concave down. The next thing we have on here that you might see on a test or quiz or the AP exam is where does it have no concavity? So recall linear functions. So if you have a graph like this and it looks like that, it's just a straight line. So there's no concave up where it has two ends opening up or down or anything like that. It's literally just a straight line. So where is our graph a straight line? Right here. So yeah, while the function you can say is decreasing, there's no concavity to that specific part. So the graph has no concavity from 0 to 1. And this graph obviously is not drawn to scale. I specifically drew in different values on the x and y plane for the purpose of this video. Okay, where is our graph increasing? Honestly, all you want to think about when you see increasing is, where is the graph going up? Where are my y values increasing as I'm plugging in x's? So, for example, on this specific graph, we would be increasing from, let's see, well, at -2 here, the graph is going up, because from this part, right, the graph is going down from here until you get to -2. Then when x gets to -2, then when we start plugging in -1, we start plugging in 0, boom, the graph is going all the way up here. So the graph is increasing from -2 to 0, because then when we start plugging in the positives, we start plugging in 0.1, 0.5, we start plugging in 1, the graph is actually going down. So we stop at 0. That is specifically, strictly where the graph is increasing. Okay. Also, it is increasing in a different spot, and that is over here. Y values, again, y values are going up. The graph is getting taller and taller. So we're going to put union. That's how we indicate that there is also a second part that we want to take into account. And that's going to start at 1 to 11. And that is where the graph is increasing. All right. And now, well, you guessed it, the next question you're going to ask you after that is, where is the graph decreasing? So now, well, if increasing was where the y values are increasing, where the graph is going up, this is just going to be where the graph is going down. So we want to take a look over here where we have these. This is all decreasing, right? And we also talked about over here where the y values are decreasing. So the y values are going to be decreasing from -5 until we get to -2, because then when we start plugging in -1, like I said earlier, that's where our graph shoots up over here. So from -5 to -2, any value we plug in between those, our graph, the outputs are going to get smaller as we progress. Okay, now it's also decreasing in another spot over here, as I mentioned earlier. That linear straight part, that is, every single, I know it only goes to 1, but think about this. If we plugged in 0.1, 0.2, 3, 4, so on, each y value, each output value we get out for those inputs that we're plugging in are going to decrease every single time. That's how you know the function is decreasing in that specific interval. So that's going to be from 0 to 1. That's where our function is decreasing. Okay, so that's basically all you need to know for topic 1-1 or 1.1. Let's kind of summarize this really quickly so you know what to take away. Okay, function and what's a function and what's not a function. A function needs to pass the vertical line test. That basically means if I take my pencil and I put it on this paper and I draw a straight line, it can only cross the graph at one point. Every input can only have one output. If I plug in, an equation into my calculator and I ask it to give the answer, it can't give me, like, okay, let's say in these graphs that aren't a function, this is not past the vertical line test because one input, this specific input, it's giving me an output up here and it's giving me an output up here. The calculator is not going to shoot out two different answers. It's not going to know which answer to shoot out. So yeah, on this graph right here, every input we plug in can only have one output. All right. And once again, with this graph as well, it's not going to pass because for that one input, we have two different outputs, and that's not going to work. And then domain and range. So these are terms you're gonna see for the rest of your life in math. Domain is all the possible input values that you can plug into this function. So those are all the possible inputs that it can take. And the range refers to the set of all possible output values that the function can produce. Real quick, in this graph, the range would be from, let's just say that's -2 or +2 to -2. That would be the range, because that is all the possible y values that it's putting out. And the x values for this, you see how it has arrows on both sides? That means the domain is all possible x values. So that's going to be -infinity all the way up to +infinity. And then really quick down here, increasing versus decreasing functions. Increasing, again, going up, right? Right here, our graph is going up. As our x values progress, as we plug in 1, 2, 3, 4, 5, as we plug in our x values, increasing, the y values are going to increase also. Okay. Now, the next one, once again, this is also an increasing function. As we plug in our x values, our y values are just going to be get bigger and bigger. And in this case, our y values are actually going to grow exponentially. Either way, it's still an increasing function. And over here, we got a linear graph. Once again, just like the first one, except it's a negative slope. So as we progress through our x values, we plug in 1, 2, 3, 4, 5, so on, our y values are just going to get smaller, smaller, smaller. We're going to go -3, -4, -5, so on. And lastly, we got one last one over here. This is basically the reciprocal function of this one over here, or rational function. This is also a decreasing function, because as we plug in, 1, 2, 3, 4, 5, we're getting closer and closer to 0. Our y values are getting smaller, smaller, and smaller. And I mean, it's kind of the same on this side. As you plug in bigger x values, you got -5, -4, -3, -2, -1. Graph is still going down and decreasing. So that basically sums up AP topic 3.1. I know I said this video was going to be short, but again, I had to introduce kind of what I'm trying to do here.